Hi guys, this video is for discussing about the homework. Now this is the exercise number 3. I know most of you have doubts about the problem, so first of all I'm going to start reading it. A 2 kilogram quantity of water is held at a constant volume in a pressure cooker and is heated by a range element. The system's internal energy increases by 8 times 10 to the third power joules. As it says increases, that means that this internal energy will be positive. However, the pressure cooker is not well insulated, and as a result, 2 times 10 to the third power joules of energy is transferred to the surrounding air. How much energy is transferred from the range element to the pressure cooker as heat? Now, if you're wondering what a pressure cooker is, I did a drawing for you, okay? Now, it says that it is heated. This pressure cooker is heated by a range element. A range element is nothing more than a portable flame, for that saying. I don't know how to say this. In Spanish we say chispero, mechero, and it's a range element because I don't need to be close to the pan to be heating it, okay? So now that you know what a range element is, this range element is going to apply heat to this system. Now take a look. This is the pressure cooker. Inside of it we have water. Now it says the system's internal energy is 8,000 joules. However, as the pressure cooker is not well insulated, 2,000 joules will be transferred to the surrounding air. That means that when you touch the pressure cooker, it's going to be hot. So it's not really safe to do it. Now, just to show you, the first 8,000 joules are inside. And in the surrounding air, we're going to have the other 2,000 joules. To the surrounding air. Now, how much energy? The question is how much energy is transferred from the range element to the pressure cooker as heat. So we're talking about the flame. How much heat is being transferred from the flame? Excellent. The special effects. Anyway, the special effects. Okay. How much is being transferred from the range element, which is a portable flame, and the pressure cooker, to the pressure cooker. So, first of all, we need to understand the problem. As we're talking about pressure cooker, as you can see, it is a closed container. That means that when the water starts to become vapor, this vapor will be moving upward, and when you have enough water in the lid, this water will be going to condensate, and afterward it will come back to the pressure cooker. Now, what does it really mean? That this 2 kilograms of water will be 2 kilograms of water. This water is not going to be wasted because all the vapor will be converted into liquid again and will come back to the same amount of water. In other words, that means that we have constant volume, that the volume is not going to change. So we were saying water vapor is not leaving the pressure cooker because it is a closed container. The vapor condensates here in the lid, okay? Then all those water drops will return to the container and will be part of the rest of the heated water. So the water volume will not change, therefore the volume will be constant, and this is no other thing such as an isovolumetric process. By definition, isovolumetric process, it has a condition that is known as no work is done by the system. Remember the table that is in the presentation that I sent you, okay? So, if you don't remember, I have it over here. Isovolumetric is the first process over here. It says condition no work is done. Therefore, delta V, or change in volume, is 0, and the change in the internal energy will be equal to Q, or to the heat. Okay, so we already know the first law of thermodynamics. We know that delta U is equal Q minus work. As this is a constant volume, we know that we have an isovolumetric process. I don't find my okay. So from the givens, we start writing. Okay, I already listed the givens over here. As we already said, that is isovolumetric process. We know that work will be equal to 0. As the work is equal to 0, we will know that the change in the internal energy is going to be equal to Q. Now, it's giving us a mass of 2 kilograms, and let me tell you that that is not very much important. Now, it says that 2000 joules of energy is transferred to the surrounding air. That means that part of the internal energy is being transmitted or transferred to the air. So, analyze the figure that we have over here. This flame should be capable to give not just 8,000 joules from the internal energy, but also be capable to give 2,000 joules to the surrounding air. So, you have to analyze this part. If I say that the flame gives me only 8,000 joules, that means that the internal energy is not equal to 8,000 joules. It's going to be 6,000 and 2,000 outside, which is not true, because the problem is telling you that there are 8,000 joules internal, okay, the internal energy of the system. So, what am I trying to say with this? That this flame should be hot enough to produce not only 8,000 but also 2,000. So, the internal energy will be 8,000 joules, but also you need to add all this energy to the surrounding air. That is the energy that is going to be lost, because it's not going to be inside the system, it's going to be lost. As it is going to be lost, you need to include it in the system. So you say 2,000 joules. So this is delta U internal energy plus the energy outside the pressure cooker. That is all the heat required by the system. Now 8 and 2 gives you 10,000 joules equals the heat. That is the heat that should be able to produce all this system energy. What am I going to say with this? Okay, this is how I solve the problem. So we're going to discuss this in class. But just the conclusion of the problem is if let's change. I mean, energy is not something that we can actually see. Okay, so let's say that instead of energy, let's talk about hamburgers. I don't know why I'm always talking about hamburgers. I don't even like them. Okay, let's talk about hamburgers. So I'm saying that here in the system I have 8 hamburgers. But the system, as it is not insulated, is not well insulated, 2 of those hamburgers are going to be leaving the pressure cooker. Now, how many hamburgers do I need to introduce in order to have 8 and 2? I need to introduce how many hamburgers? 10. Because if I only introduce 8 hamburgers, that means that the system is perfectly insulated, and that all this heat is not going to be transferred to the surrounding air. But that is not true, because the problem tells you the pressure cooker is not well insulated and energy will be transmitted to the surrounding air. So how much does the flame need to give to the system? It needs to give not 8 but 10,000 joules. If you have 10 hamburgers, 2 outside and 8 inside, you need to plug in how many hamburgers? 10. That's how you analyze this problem. It's a little bit more tricky than the rest of them. That's why I decided to do a special video for it, and I'm going to share it. See you.